the next session on ANSYS Workbench tutorials. In this session, we are going to analyze a piston ring for modal analysis. We want to see what is the natural frequency of the piston ring at which it will show certain amount of deformation. We are going to check at least 6 modes of vibration wherein we will find the 6 natural frequencies of the piston ring. The higher the value, it is better, because in that case the object will be more safer, as it is difficult to reach that higher natural frequency. So we want to see what will be the natural frequency of such a piston ring. I have already created the design of it, for which we have already seen the structural thermal analysis. So we will now check the modal analysis. We will start by double clicking on modal module. We will first go to engineering data. The material that is used for piston ring, as you know by now, is either cast iron or stainless steel. I have selected both of them. I'll go to project and update project. I'll go to geometry and right click, import geometry. I have already made the model, so I directly imported the model here. Now I'll go to model and double click. We will first assign material as grey cast iron. I'll go to mesh and change the sizing to fine and update. Next I'll go to model and insert fixed support. As you have already seen the static structure analysis, these two ends are fixed. Next I'll go to solution and solve first. If you go to analysis settings, you will see that the maximum mode is always set to 6 by default for ANSYS. So in the solution we have got the 6 modes. I will go here and right click, select all, create mode shape results. I'll go to solution and solve. So you can see here these are the frequencies that we have obtained, and this is a deformation value at this high natural frequency. This frequency is really very high. It is 3.8 into 10 raised to 5 hertz, which means it is really a large value. And at this frequency, you will see a deformation of 4567.1 mm. This is also a very large value. It is 456 centimeter, which means it is quite large. But also the natural frequency is very high. So it is technically not possible to reach this natural frequency. So you will never see a deformation of this sort. But we are just doing the analysis to check as to what will be the natural frequency of this material. You can animate and check the result. We will go to mode 2. You can see the frequency is 3.8 into 10 raised to 5 hertz, and here the deformation is 4660.1 mm. If you want, you can check the animation. This will show how the body is going to deform. Next we will go to mode 3 and animate. The deformation is 2216.5 mm and the frequency is 4.039 10 raised to 5 hertz. For the fourth mode, you can see the frequency is 4.042 into 10 raised to 5 hertz and the deformation is 2251 mm, which is again a very large value. So this is deformation 5. You can just animate and check the result. And the values are given here. And for the last one, your frequency is 4.137 into 10 raised to 5 hertz, and the deformation is 408.08 mm. It is reduced. So that's how you're going to find these natural frequencies. But the material we have used is grey cast iron. So we can just change the material and go to stainless steel and see if the results are different than this. We can go to first deformation. Here the natural frequency is 4.8 into 10 raised to 5 hertz, and the value of deformation will be 4352.2 mm. You can animate and check how the deformation is going to occur. For the next mode, your value of frequency is 4.81 in 10 raised to 5 hertz, and the deformation is 441.6 mm. Again, we can check how it is going to deform. It is just the sides have changed. For mode 3, your total deformation is 2072.9 mm, and the frequency is 5.1 into 10 raised to 5 hertz. The frequency is increased. This is how it is going to deform. Next, in mode 4, the value of frequency is 5.11 into 10 raised to 5 hertz, and the deformation we see is 2112.4. The deformation has reduced as compared to the previous mode, and you can see its motion. Similarly, you can check for mode 5 and 6. The value is increasing 5.22 into 10 raised to 5 hertz of frequency. But if you check here, the deformation value has reduced. It is 437.9 mm for mode 5, and for mode 6 it is 393.9 mm. That's the maximum value that we are checking out. So between grey cast iron and stainless steel, you can see that for stainless steel, the value of natural frequencies, the higher natural frequencies that we are checking are greater. Also, the deformation in certain cases are more and somewhere it is less. It is always better to go for a material which will have higher natural frequencies, which will be difficult to tap because of vibration in the total assembly. So, if given a choice, stainless steel would be a better material because its frequency is natural frequency value is higher, so it will be difficult to reach that value, and hence the body will never go into resonance and show this kind of a deformation. So with this I end the session. I hope you have understood how to analyze a piston ring for modal analysis using stainless steel and grey cast iron as a material. If you have any doubts, please write to me in the comment section. Don't forget to like, share and subscribe to the channel. Hit the bell icon for latest video updates. See you in the next session. Thank you.